Hey guys, good evening. Hope I'm audible and visible. Can you guys see me, hear me? If so, say me a hi and a hello. It'll be great to start the session. So tell me honestly, how many of you guys went back yesterday and read Robbins? At least did you even make an attempt to go through Robbins? Yes, no, maybe. Good evening, Gene Savvy. Gene Savvy. Okay, fine. Great. Just give me a second. Okay, fine. So let's start today's lecture. So today we are going to talk about stem cell. This is the second CBME in the competency which is there in your CBME curriculum. They are going to talk about the stem cells and the utility of stem cells. This is also there in the first chapter in Robbins, which is cell, the unit of health, right? Good evening, Alka, Alok, Ankit, and everyone. Fine. Okay. So I hope you must have read yesterday the cell cycle thing. If you have any doubts, you can ask me at the end of the session, or if you're in the part of the Telegram group, you can ask me on Telegram, or if you're there in Instagram also, you can ping me on Instagram. Fine. So let's start about stem cells. Again, the same way like yesterday we started. Can anyone tell me what is the definition or what comes to your mind when you think of stem cells? Anything which comes to your mind. Good evening, Garima. I'm doing good. Hope you're doing great as well. Tell me whatever comes to your mind when you think about stem cells. Okay, this is what stem cell is. Because I'm sure you must have heard about stem cells way back in your first year, even sometimes in your 11th, 12th standards, right? Okay, Samantha's come up with a word called as totipotency. Fine. Snehajit, Warburgs, I didn't particularly mention about Warburgs because we'll read about Warburgs when you come to your neoplasia chapter. Fine. Bone marrow, fetal life, undifferentiated cell, right? Which can generate any type of cell, right? All of you here are partly right, right? Stem cell is a very undifferentiated cell. Stem cell has the capacity to divide to any different type of cell. We call that totipotency, right? We'll come back to totipotency soon, right? So the definition of stem cell, it's an undifferentiated cell, like you guys said, with a very unique ability to develop into various specialized cell type in the body. This is the definition in Robbins. It's a very simple definition. I hope you can write in your own words. We are not in 11th standard, 12th standard where I have to write exactly the way it is given. If the word is conveyed, if the meaning is conveyed, that's more than enough. Fine, perfect. Okay. So I'll give you an example. Let's say I have a skin cell, right? When a skin cell divides, what do you think will happen to the daughter cells? Will they become same skin cell or they will become a different cell? What will happen? If a skin divides, will it become same skin or it will become something different? It will become same skin cell, right? So stem cell, as the name says, it said it can become various specialized tissues in the body, right? So there is some unique quality of stem cell which is not there in any other cell, right? We have two types of divisions in stem cell. One is called as a symmetrical division of stem cell. The other one is called as an asymmetrical division of stem cell, right? Let's understand what is symmetric and asymmetric mean. I am sure that you know the English symmetric and asymmetric. Symmetric means same. Asymmetric means there is some amount of differences, right? Now, when I have a stem cell here, so what do I mean by symmetric division is the stem cells divide and gives rise to two stem cells. Again a stem cell comes, again a stem cell comes. This is called as a symmetrical division, fine? So as the name says, asymmetrical division is very, very simple to understand, right? Good evening, Max Code. Asymmetrical division means I have a stem cell, where the stem cell divides, right? So one again becomes a stem cell, which creates the pool of stem cell. The other cell kind of matures. Okay. For example, when I take skin, my skin stem cell divides and gives rise to one keratinocyte. That's a skin cell. The other one goes back to the stem cell, right? This is called as an asymmetrical division because one matures, other one goes back to the stem cell pool. This quality is very, very important because if I have a stem cell today, I'm going to divide into two cells. If both matures, will I have the stem cell third day? I won't have. So I cannot keep on dividing because like you guys said, one of the important property of stem cell is it keeps on dividing forever throughout my life. For that life, I require this asymmetrical division. That's very, very important. Fine. Sorry, sir, I missed my textbook today also. Next class, I'll definitely take it up. Tell you, fine. Okay. So I have symmetrical division and I have asymmetrical division here, right? I'll give you two instances. I want you to tell when symmetrical division is more important for me and when asymmetrical division is more important for me, right? The first situation is it's a fetus, a very newly born fetus, maybe just now implanted fetus, and it's growing fastly. Second is in adult life. In which of these instances, in fetal life or adult life, you require symmetrical division? Or in other words, in which of these two instances you require stem cells to just to divide and not much to mature? When do you think you require symmetrical division? Whatever comes to your mind. One or two. Anyway, you're 50% right. The symmetrical division is very, very important in the early stage of the life, right? Perfect. In the fetal life, when I'm from a single cell stage, I'm becoming 2 cell, 4 cell, 8 cell, you must have read, right? So in fetal life is where my symmetrical division predominates. It predominates during the fetal life or most likely your embryonic stem cells. And the blastocyst stage, it'll have, right? Asymmetrical division happens predominantly in the latter half of fetal life, because latter part of fetal life also I require maturation, right? If it doesn't mature, it will still be a fetus. It has to grow to a full born baby, and also during adulthood, right? Samantha, asymmetrical means I gave an example of skin cell, right? Can anyone tell me which layer of skin divides? You must have read in your first year. Which layer of skin divides? The stratum basale or the stratum germinatum, right? So when I have a stratum germinatum, there's a stem cell in the stratum germinatum that divides and gives rise to a skin cell which becomes your stratum spinosum, stratum granulosum, stratum corneum. That's how it matures. The one more part, this becomes again my stratum basale, so that it is required for the next division. That's what I mean by maturation. When I take my bone marrow, the hematopoietic stem cell, one divides, gives rise to RBC. The other one stays as a stem cell. That's what maturation and asymmetrical division means. And that happens predominantly in adult and the latter half of fetal life. And this happens very early stage of your embryogenesis, right? So these are two unique property of stem cell. They can divide in a very different way compared to the other cells, right? So now we know about stem cells a little bit and about the differentiation, right? Then I'm sure you must have learned about the term potency, right? Totipotency, some of you even mentioned in the comments, right? So I have 4 different types of potency. I want you to remember this throughout your career because we'll keep using this again and again, right? So you have totipotency, we have pluripotency, we have multipotency, and we have unipotent, right? Totipotent means this can give rise to all 3 germ layers, and also it can give rise to extra embryonic tissue. Hello Osama, how are you? Okay, so what do I mean by extra embryonic tissue? Can anyone give me one example in your entire life which is extra embryonic, which is not a part of me? Any example which comes to your mind? Because it's very, very unique and only totipotency can give that. Extra embryonic tissue, the most important extra embryonic tissue is placenta. Placenta is a fetal part or the maternal part? Placenta is from the mom's part, right? So what happens is the fetus also contributes to a little bit of your amnion, a little bit of your chorion, a little bit of placenta. They are not embryonic. They are not a part of the hardcore embryo, but it's outside, right? So a totipotent stem cell, which is very, very, very early in life, contributes a little bit of chorionic trophoblast. It helps in the formation of placenta, though not completely, but it has a major role in that, right? Okay, I'm good, Kosama. Pluripotency. So when I use the term pluripotent, which means it can give rise to all 3 germ layers, which means this cell can give rise to endoderm, mesoderm, and your epiderm, right? All the 3 germ layers, this particular stem cell can divide, but it cannot give rise to the extra embryonic tissues. None of the zygotes extra embryonic tissue it can give, right? So multipotent means multiple, right? I'll give an example of bone marrow. I'm writing BM for bone marrow, the hematopoietic stem cell, right? Tell me, a hematopoietic stem cell should give rise to only RBC or RBC, WBC platelets, all of them? What do you think? Only RBC or all 3? Has to give rise to all the 3 of them, right? That's multipotency. At the same time, will a bone marrow stem cell give rise to skin epithelium? It's fine, Garima, because you must have learned about teratoma. That's all. It's completely fine. It cannot give rise to skin, right? Multipotency can give rise to multiple cells in the same lineage. That's one of the example. One more example here is I have something called a mesenchymal stem cell. So when I say mesenchymal stem cell, this stem cell can give rise to all the derivatives of mesenchyme. Am I right in saying that bone, cartilage, muscle, all the fascia, everything is mesenchyme? Fat, Everything is, right? So I have mesenchymal stem cell which can give rise to all these mesenchyme, but at the same time this mesenchymal stem cell cannot give rise to epithelium. They can give rise to only mesenchyme. They are multipotent, they are multiple. Last is unipotent, right? The best example for them is skin. In skin, you had basal layer, stratum germinatum, that's a stem cell. Do you think that will give rise to dermis? It will not. Adnexal glands, it will not. It will give rise to only epidermis. One single thing. Can I say GI epithelium has stem cells? Have you heard about something called an crypt in the duodenum and small intestine? Crypt. You must have definitely learned about crypts of Lieberkühn, right? So the crypt is where I have the stem cell. The crypts gives rise to only epithelium of the GIT. The crypt will not give rise to anything else. The crypt will not give rise to RBC, WBC, right? That's unipotent, fine? Great, Robertson, right? So we have multipotent, we have unipotent, we have pluripotent, and we have totipotent. We will be using this when we go to pathogenesis. I want you to make sure you will never do a mistake here. Totipotency means totally everything, right? It's totally everything, 3 germ layers plus extra embryonic tissue. Pluri is all the 3 germ layers. Multi is multiple cells in the same lineage. It will not cross the lineage. And unipotent is only that particular cell, fine? Yeah, sure, in stomach as well, fine. Okay, now these are the potencies of a stem cell. It differs according to different thing, right? Now there are different types of stem cell. Let's have a quick look about the types of stem cells, right? One is your embryonic stem cell. Can anyone tell me what will be the potency of embryonic stem cell? A totipotency or multipotency or pluripotency or unipotency? Just to make sure if you've understood it or not. Embryonic stem cell is the most undifferentiated. It will be seen in the blastocyst. You must have read about blastocyst. The inner mass of blastocyst will have this, right? It will be there in the blastocyst. When it's there in the blastocyst, it's the most undifferentiated. Obviously, it will be totipotent. Totipotency will be there, and they are very, very undifferentiated. Especially when they are very, very undifferentiated, can I say that they will have more of symmetrical division than asymmetrical division? Definitely. They'll have more symmetrical division than an asymmetrical division. But again, the latter half, the symmetrical division might go towards asymmetrical division. Fine. That's a property of stem cell. It can have both symmetrical and asymmetrical division, right? That we need not read about it for the only reason. Tell me, is there any chance embryonic stem cell will be useful for treating patients? Or in other words, can I take embryonic stem cell of any born baby in the world? Is it possible to take the cell from the blastocyst? It is not possible, right? So if it's not related to my patient management, I would say it's not required. Let's leave it. That's all. It's there for historical importance. It's there because I cannot take it at any point of time. I cannot use it for any point of time. But yes, I do have stem cells. That's what gave rise to you, me, and everyone in the world, right? Then this is what I'm more concerned about. The adult stem cells. Yes, Satyajit, we are all doctors here. Hopefully you also will become a doctor and let's learn together soon. Fine. Okay. So tissue stem cells, or we call it adult stem cells. In adult stem cells, I can have unipotent adult stem cell. I can have multipotent, and sometimes I can have pluripotent also. I'm not talking about pluripotency here. Let's go and discuss about pluripotent adult stem cell when you come to hematology. Fine. So stem cell niches are the places where niche is a place where the stem cells are located in the particular organ. For example, like I said, crypts. Crypts are the place where I have the stem cells in case of a GIT, right? So stem cell niche is a place where the adult stem cells are located in different organs in different places. Okay, so there are few places which are mentioned in Robbins which I want you to remember to some extent, right? There is a bulge in the region of hair follicle. That's where the skin stem cells are there, right? Samantha, because it's very, very early in life, because in very early in life, I need more symmetrical. Saida, same reason. When I am a blastocyst, tell me what is important for a blastocyst. Should they produce skin GIT or they should divide to make it a bigger mass? Blastocyst. Blastocyst is very, very early, right? Your organs start developing after few weeks of your intrauterine life. You know embryology better than me, right? So till the time organs start developing, my goal is to produce cells. That's all. Not to produce and developed organ. Once, let's say, after a few weeks, heart starts appearing, then I would require more asymmetrical division than a symmetrical division, right? It's just a very continuous spectrum where it's different there, fine? It should be very undifferentiated, right? Okay. Now let's go to few stem cell niche which is there in your organs, right? One, it's in the bulge of hair follicle. There's a good image there also in the stem cells. If you go after the class, go and have a look. The bulge of hair follicles, we do have little good amount of stem cell, right? Can anyone tell me where have you heard this name before? Canals of Herring. Anything rings a bell? Canals of Herring. I'll come to Snehajit. I'll come to it. Canals of Herring in your liver, right? In liver, we have a stem cell called an oval cell. That's a stem cell's name in your liver. It's close to that, right? You have canals of Herring. So herring canals or canals of Herring is seen little bit in and around the portal triad in that area. That's where I see the canals of Herring surrounding the bile ductules, fine. And you have in the crypts of intestine. Okay. Not every stem cell niche is a unipotent example. I am just writing the things which are unipotent under this example, fine. Skin is unipotent. Liver is unipotent. Hair follicle, crypts, everything here is unipotent. Again, adult stem cells have multipotent also. These both are multipotent examples of adult stem cells. Here, they are unipotent examples of adult stem cells, fine. Herring pattern is different. It's just a canal of Herring. It's a structure like your, there are multiple structures in the liver. One of the structures is the canal of Herring, which is seen around the bile ductules, fine. Okay. So these are places where I have unipotent adult stem cells. And these are stem cell niche is nothing but the area where they are seen. That's all, right? Now let's come to hematopoietic stem cell. So when I say hematopoietic stem cell, this is most of the time multipotent. I will tell that hematopoietic stem cell can also be pluripotent when we come to hematology, but for now I am keeping it easy for us, not too much to confuse. They are multipotent most of the time. Hematopoietic stem cells can give rise to RBC, can give rise to WBC, and can give rise to platelets. Most of the time, right? There is one more cell which a hematopoietic stem cell gives rise to. Can anyone answer that? If you have read about good understanding of embryology and histology, there's one bone cell which comes from hematopoietic stem cell. Anyone? The origin of a bone cell, I'll give you a clue. The function of this bone cell is to eat the bones. That also comes from hematopoietic stem cell only. Your osteoclast, right? It's not just this. Your osteoclast also comes under them, right? Osteoclast origin is from hematopoietic stem cell. They are not coming from the mesenchymal stem cell, right? Perfect. That's how they are like a macrophage. They are multinucleated, kind of like a macrophage. It does the function, right? That also comes from hematopoietic stem cell, fine. We'll look at the use case of hematopoietic stem cell very soon, and I do have mesenchymal stem cell. Mesenchymal stem cell is a recent development. So what we found was, initially we thought when I took a stem cell which produced fat, I thought that it will produce only fat. Mesenchymal stem cell were thought to be unipotent. Right now, we know that for a fact that mesenchymal stem cells are also multipotent. Mesenchymal stem cells are used a lot in gene therapy because I'll tell you the reason. I want you to tell the reason. Used in gene therapy. We'll talk about gene therapy and the stem cell therapy very soon. Fine. Tell me, why do you think a mesenchymal stem cell is useful for gene therapy compared to my hematopoietic stem cell? What is the difference? Just think out loud and tell me why. I would prefer taking a mesenchymal stem cell for gene therapy compared to my hematopoietic stem cell. Why? It's a very simple answer, but it's a very practical answer. Any guesses? Think, comment. If it's wrong, it doesn't matter at all. Yes, then we do use hematopoietic stem cells only in bone marrow transplant. Gene Savvy, I think you read the book, right? I don't ask questions from book. One is ease of taking it outside, that's all, right? It's very easy to take an hematopoietic mesenchymal stem cell compared to a hematopoietic stem cell. For a hematopoietic stem cell, I need good amount of your bone marrows to take it, or I would require to push in some drugs to remove them, right? But mesenchymal stem cell are easy to take. That's the only reason. And Gene Sebi and Priyanka said, it has little bit of less rejection quality. We'll see why very, very soon. Fine. It's predominant of ease of access, and this can give rise to any mesenchymal tissue, can it be bone, your cartilage, your muscle, any of the mesenchymal tissue, it can give rise to, right? That's how it is. Fine. Okay. Textbooks are there, but what I want is, I want you to think as a normal human being, because textbooks will make you a good student. When you think as a normal human being, you become a good doctor. Don't think too much. Whenever you overthink, tell me honestly, you make mistakes or you don't make mistakes. You have given your first year exam in Viva or wherever it is. When you overthink, what happens? Generally, we tend to do a mistake, right? Think simply. Most of the time, you'll be right, because it's the knowledge which you have accumulated over the period of time coming. And when you overthink, most of the time you do mistakes. Think normally. That's more than enough. Fine. Okay. Now we know a little bit of understanding of stem cells. The only reason why I am need to learn about stem cells is because this is one cell which has n number of capacity to divide. I am sure you must have seen newspaper articles saying that with the help of stem cells, we recreated heart, we recreated tiny little organ which is pumping, we recreated a kidney, right? The only goal here is I can use them in regenerative medicine. So the applications are numerous. I'll tell you few applications. Like Tanmay said that it can be easily useful for BM for bone marrow, again bone marrow transplant, right? It can easily be useful for bone marrow transplant, right? Can I use it for skin transplant? One of the burning problems of the younger generation, right? Definitely I can use it for skin transplant. Can I use it for any organ transplant for that matter? Not just bone marrow. If I have a mesenchymal stem cell, can I start creating cardiac muscle? Yes, like Meet said, I can use for treatment for diabetes. I can produce new beta cells. I have a stem cell which can create anything what I want to. The common thing which is being used is bone marrow transplant, but in textbook, it can create any organ or cell. If I have a patient whose kidney is failed, in theory, in principle, I can take a stem cell and I can create a kidney, right? I can create a kidney. Regenerative medicine is what I told as gene therapy. Anything involving this is going to be called as gene therapy. I'll tell you why I named them as gene therapy soon. Fine. Okay. Now I have a problem statement here. What is this problem statement? Fine. Right. The problem statement here is one. I can create a cardiac myocyte, but I don't know how to make them in sync with the muscle in the heart. Because creating a heart outside does not mean that it should react with and sync with my SA node. If it's not functioning with my SA node, AV node, bundle of His and Purkinje fibers, this muscle is waste. I can create a part of intestine, but if it's not undergoing peristalsis, that intestine is waste, right? One of the biggest problem is I am not able to yet functionally integrate into the cells, into the site. In few places, I'm successful, like bone marrow. I'm definitely successful, right? One of the biggest problem statement is functional integration. I can create a neuron, but I cannot create memory. I cannot make them functionally integrate, right? So that's one of the biggest challenge for me, functional integration. Hopefully in future, I'll be able to functionally integrate. That's the hope, right? The second. Diabetes was never genetic, right? Some little, very few parts of diabetes are genetic. But in any patient with diabetes, the primary problem is beta cell will get exhausted. Type 1 it get destroyed, type 2 it will be exhausted, right? At that time, I can create beta cells in my lab and put it into the patient so that it can produce insulin ultimately, fine? Okay. Obviously, Tanmay, you must have read about nerve growing and regrowing, right? In your first year, Wallerian degeneration. It's very, very slow and very, very difficult, right? I can integrate. Will it function? It takes its own sweet time for it to function. Maybe 1 year, 2 years, sometimes might never happen, right? So functional integration is a problem. Biggest challenge for me, I can produce a kidney, I cannot make it functional. That's one of the biggest challenge. Hopefully we'll find a way. The second biggest challenge is, let's assume Tanmay is here, right? I'm sorry to take your name. Since you commented, I'm taking your name. I'm having a problem with my muscle, let's assume, okay? If I take Tanmay's bone marrow stem cell or some stem cell of Tanmay and I'm creating a heart, can I give it to me? Will there be a reaction? Will there be a rejection? there'll definitely be rejection, right? Because HLA will not be the same. Your major histocompatibility complex, you must have read about those, right? I will have rejection, right? I'll have a mismatch. Because why I'll have a mismatch is वैला हिंदी में पढ़ा हिंदी थोड़ा प्रॉब्लम वैला आप आपका जवाब नो हिंदी से पूछो और मैं जवाब इस क्वेश्चन राइट मैं उसका आंसर अंग्रेजी से बोल सकता हूँ ठीक है लिटिल बिट ऑफ प्रॉब्लम ओके okay rejection is a problem right rejection is a major problem here because of HLA incompatibility rejection is a big issue it will reject if I'm going to take someone else's stem cell and going to give it to me it will my body will automatically reject it right for this we had a solution how many of you have heard about cord blood sampling we had a solution to this. How many of you have heard about cord blood sampling? Once the baby is born, if you have your sisters or brothers in your home, they must have definitely told about cord blood sampling. HLA, you will read about HLA soon in your microbiology as well as in pathology. It's your human leukocyte antigen or your major histocompatibility complex, which is involved in immunological rejection. Fine. You've not heard about it. Okay, fine. So there's something called cord blood sampling. When the baby is born from the umbilical cord, can I say it'll have good amount of stem cells? Because it's from the fetus, right? When the baby is born, the umbilical cord blood is pluripotent. It can give rise to anything in the body, right? So if I'm going to, let's assume I was born, I took my stem cells and I stored it in the freezer for let's say 20 years. After 20 years, I had a problem in my finger. I have to recreate this finger. Can I take the stem cells and recreate the finger? I can because that my stem cell can give rise to anything. It's pluripotent, right? Will I have a problem of rejection? Because it's my stem cell and I'm recreating my finger. Will there be a rejection or not? There won't be rejection, right? Only when I take someone else's stem cells, I'll have the problem of HLA incompatibility, right? Here, the rejection is very, very less. Afsal, I really don't know whether the practice is there or if it's scientific enough to prove it, right? Okay, so here this can be circumvented. I have a solution for this. One of the solution is umbilical cord blood, right? You can have umbilical cord blood stored, but this cord blood can be used only for me. Can I use my stored blood for you? I cannot because same problem, HLA rejection will happen, right? I can use my stored blood for me. But how many blood samples will I store thinking that in future I'll have myocardial infarction? Even if it happens, I don't know still how to functionally integrate it, right? This is a very short-term fix. I'm storing it so that I can prevent a problem, right? Now, if I can store my stem cell and only treat me, I need one more solution, right? The solution for that is this, induced pluripotent stem cell. Samantha, this is what I told about gene therapy, right? Now, let's take, I am taking a random cell from my body. It could be a mesenchymal stem cell or any cell, right? Let's take, I'm taking some differentiated cell also. Let's take, we take fibroblast. Fibroblast is one of the commonly used one because fibroblast is something which is easily available for us. No, Jayanti Reddy, it cannot be given because siblings also have a different HLA. The only person who can get that is an identical twin. Okay, fine. Why, Sumit? Can you tell me why? Okay, now let's take, I took a fibroblast. That's from your skin. I take a skin biopsy, I take a fibroblast. This is a very mature cell. So what I do here is, I introduce something called as an genes which can provide stemness. See, all the thing in our body is controlled by genes. There are few genes which can provide stemness. We'll talk about those genes a little bit later. Okay, fine. So now here, what happens here is, I have a few fibroblasts. I'm taking your fibroblast. I'm putting into the fibroblast genes which will give stemness to the fibroblast. So can I say I'm inducing the cell to become a stem cell? Right? So in other words, I am reprogramming the fibroblast to a stem cell, right? This is what I call it as a gene therapy, right? Any one random person has a problem. I call that person, okay, kidney failed. Let's take the fibroblast of the person. Into the fibroblast, let's put some genes to make the fibroblast a mesenchymal stem cell or a pluripotent stem cell. Actually, I'm inducing pluripotency here, right? So when I reprogram the stem cell, it becomes a pluripotent stem cell. Okay. When it becomes a pluripotent stem cell, obviously then my fibroblast is a very differentiated cell. That's why I'm saying I'm introducing genes which give stemness. Once this becomes pluripotent, okay, tell me what you're not able to understand, Sumit. I'll definitely help you. I'm here to help you. If English is a problem, I'll tell slowly, okay? But obviously the goal is to make you understand, okay? So this pluripotent stem cell can give rise to my RBC, can give rise to my kidney, can give rise to my CNS, can give rise to my heart, everything, right? Kind of like, I wouldn't call it a de-differentiation because it's I'm introducing few genes to give a property of the stemness, kind of like a de-differentiation, right? I'll repeat it once again. I had two bigger problems. One was HLA incompatibility in your stem cell therapy or in your regenerative medicine. Other one is functional integration. This still I have not found a solution for this. Maybe in future we might. To circumvent the problem of immunity, we started storing cord bloods. But cord blood is very, very difficult. Okay. Cord blood is very difficult for me to store. It requires lots of money. It requires lots of storage for a very long time in -80 big freezers, which is a bit difficult comparatively, right? So what we thought is, let's take a fibroblast. I'll definitely do it, Sumit. Whatever you want to ask, please let me know which you're not able to understand, fine? For example, let's take a fibroblast. Rishikesh, why fibroblast? A very good question. I can take any cell in my body, right? But when I take a biopsy of skin or any organ, fibroblast is something which is more resistant, which is more adaptable, and which is easy to introduce few genes and come out, right? That is the only reason I prefer fibroblast. But like you said, any cell, most welcome, Sumit. Any cell in the body, I can change it. I take a fibroblast, it's a mature cell. I introduce few genes which give stemness. One of the important genes is MYC gene. We'll look at this gene sometimes down in future. This is one of the important gene which I put into the stem cell. Once I put this gene into the stem cell, into the fibroblast becomes or reprograms into a pluripotent stem cell. No, Abu Bakr, any cell in the body. I can change any cell into pluripotent stem cell, right? Abu Bakr, now tell me, if it's pluripotent, can it give rise to all three germ layers or can give rise to only that organ? What's your take? If my kidney fails and I have a pluripotent stem cell, can it produce a kidney? It can produce a kidney, right? Because pluripotency can give rise to all three germ layers. So what I am introducing is, I am making a cell extremely potent so that it can give rise to my endoderm, epiderm, and your mesoderm, right? All three germ layers, right? So this is what called an induced. I'm inducing the pluripotency of a cell in the lab. So we call it an induced pluripotent stem cell. This is what we have latest. In spite of this, can I functionally integrate? That's still a challenge, right? That is still a challenge. Functional integration is not that much easy in case of stem cell. I can produce a kidney, which will be a kidney, which will do the function of the kidney outside the body. But inside the body, I don't know. Because it's very complex. It's very, very complex to make a cardiomyocyte and make it respond to my Purkinje fibers. It's very difficult to do that, right? I have the capacity to create a kidney, to create a muscle, to create a neuron. But functional integration is still a problem for regenerative medicine, right? In few places, I don't require that. This bone marrow, it will automatically be taken care of. It's not much of a problem for bone marrow, but rest of them, we do have a problem. Mausam, you will have something called as a combo pack of first and second year. Please have a look at that. Okay, meat, whenever I use the term somatic, it's a cell which is there in the body. Whenever I use the term germline, it's related to your spermatogonia or your oogonia, the germ cells. No issue, Sumit. You're a kid, right? It's completely fine. It's not about misbehavior. Maybe the way it's comment, right? If you have met me in person, you'd have definitely told I'm not understanding. Comment always looks rude. It's completely fine. It's not a problem. Okay, great. So that's about stem cell. So it's a very simple thing. I hope you are in the Telegram group. If not, please come to the Telegram group. I'll give you the entire thing with you. I just want you to write along with me. Stem cells are undifferentiated cells. They have the capacity to divide anything. There are two types of divisions in stem cells: symmetric, very early in fetal life; asymmetric, little bit later in fetal life and during adult life, right? I have four different types of potency: totipotency, pluripotency, multipotency, and your unipotency. Fine. Okay. And we have different types of stem cells. Embryonic stem cell, not much of use. Very early symmetric division and always totipotent. Adult stem cells, I have some of them which are unipotent, like in your skin, in the hair follicle, in the liver, and in the crypts of intestine. I have few stem cells in adults which are multipotent. Hematopoietic can give rise to RBC, WBC platelets, and mesenchymal can give rise to anything here. Most of the stem cells which are used for therapy are taken from mesenchymal cells only. Okay. I'll answer your question. Fine. Ayodhya Prasad, unfortunately, what आपका question क्या है? बोलो, I will try to answer. Fine. Okay. Great, Gaurav. I'll answer your question. Just give me a second. The problem with using stem cell for treatment is bone marrow transplant, and also I can recreate everything, but the only problem is functional integration and my immunity problem, right? So immunity can be taken care of by a solution of your taking umbilical cord bed or by inducing pluripotent stem cell of that particular person, so it's not a problem, but still functional integration is a problem. Okay. Snehajit, cornea transplant, what I do is, let's say that a person dies, we will take the cornea of the person and I'll cut my cornea. If let's say my cornea has a problem, I'll take that and I'll just transplant. Cornea transplant has nothing to do with stem cells. It's a transplant of a mature organ, like kidney transplant. I take my kidney, put into another person. It's a physical transplant. That's different from this. Osama, my Hindi itself is a problem, right? If I integrate with medicine, दिमाग का flow cut हो रहा है, right? I don't want to spoil your understanding of patho with my stupid Hindi. Okay. I'll try to learn for sure. You guys are there in the Telegram group. Please talk to me only in Hindi, be it Instagram or Telegram. So slowly I'll try to learn a little bit of better Hindi. Fine. Sayan, can't we store inside the body? It's a very good question. Maybe Sayan, I'll want you to research more on that and let's see if it's possible to maybe grow inside the body so functional integration can be taken care. Nikhil, we are just starting it. You have a 1 year. I'll make sure you will learn pathology for sure. Abu Bakar, go with Nishchay if you are there in the Nishchay. Here I'll take tiny topics so it's easy in the start. Nishchay will be 2 hours lecture. That's the only difference. Like I said, Sayan, it's a very good idea. Pursue the idea. Let's see if it's possible. Okay, so let's have one question. I have given this question also in the PDF before. Let's see if you're able to answer the question. Roy, I'll try to reduce that a little bit. Read the question, tell the answer. Yes, Abu Bakar, only one book, Robbins Forever. Okay, what do you think is the answer? See, there are 4 options, right? The best part about an MCQ is, by default, even if you close your eyes and answer, 25% you will be right. So it's fine to make a mistake, but read carefully all the 4 options and go with that. Fine. Rahul Bhai, all the best for your NEET. The first one, amazing, right? So this is a concept of induced pluripotent cells, right? Let's look at the other 4 options also. They can replicate indefinitely. Yes, because I am reprogramming them into a stem cell, right? And can differentiate into any stem cell found in the body because it's pluripotent. Pluripotent will definitely reprogram to everything else, right? They are derived from blastocyst stage? No. It's induced from the fibroblast, not from blastocyst. They are only capable of producing hematopoietic lineage? No. It is capable of producing everything because they are pluripotent. They retain original fibroblasts even after reprogramming? No. Once they reprogram, they will not retain the function of an original fibroblast. Fine. So the option A is the right answer, and amazing, most of you guys were right. Okay. For your 2024 prof, the foray will start soon. I think your syllabus, your exam timetables are coming soon. Most likely in the mid of December. We'll definitely start the foray soon. Fine. Okay, that's all for today. A Telegram group, I will not be able to share it here. If you follow me on Instagram or if any of your friends are there in the Telegram group, ask them to share the link with you guys. Fine. Okay. So any doubts in yesterday's class, do ask me. Feel free to ask me. Okay. Or any doubts in today's class also, do feel free to ask me. Okay. And I hope you help me to learn Hindi. Bye bye, guys. See you tomorrow. Bye bye. All the best.